Hi everybody, I'm Steve Schaeber from MACS. The following video was recorded in February 2023 at the MACS Training Event and Trade Show in Nashville, Tennessee. As part of our MACS Pioneer video series, it's a conversation with Jeff Schultz, who received the MACS Pioneer Award at the event. Jeff spent more than 30 years working as a product engineer at Schrader Pacific, the company known around the world for their valve cores, or Schrader valves, which are used on everything from car and bicycle tires to fuel systems and, you guessed it, the service ports on mobile AC systems. In this video, Jeff sits down with Rachel Dill, who is a product design engineer at Schrader Pacific and who presented Jeff with his award. They discussed Jeff's long and storied career path from his work with sonar buoys, fiber optics, and underwater cable manufacturing for the U.S. Navy to engineering pressure vessels for the natural gas industry. They even talk about Jeff's experience raising cattle on his farm in Virginia. And now I present to you a conversation with Jeff Schultz.
I'm going to start asking you about your cows, though, because I don't even remember what kind of cows you had at this point.
Oh, the cows?
Yeah, let's
Well,
start with cows.
What I tried to do is keep the breed between Angus and Simmental.
Okay.
You want the crossbreed heterosis
Yeah.
in order to get bigger calves, and the Simmental carry a big calf, and the Angus gives you good grading when you sell them. So, you know, that's what I did. And I also bred for calving in the fall,
Okay,
so
so you did fall cycle.
I sell them in the spring when the prices were higher. And so the prices are always higher in the spring because most people do it the other way. They calve in the spring and late winter.
Well, it's warmer in the spring.
So they want to have all the grass all summer. I find it's more economic to just buy some hay and keep them over the winter. And so it was just I've always been kind of a contra thinker, you know, so people going that way, I'll go the other way. And
So now, were you cutting your own hay, or were you buying hay?
I'm buying hay, which was one of the reasons I ultimately gave up on it, because it was very difficult to find hay, at least where we live. You know, I can buy commercial hay, and it's very expensive, but, you know, I had a guy that could deliver a lot of hay at a reasonable price, and then he got out of business, and then I had to start searching around, and it's, you know, people sell you and it's like, oh, I'll sell you some if I didn't use it all, you know, so it was more of a hassle than it was worth, you know, unfortunately.
Were you doing 5/8 crosses with the Simmental to the Angus, or were you doing 50/50? Is it just kind of the run of whatever that?
You know, I didn't have enough. I only had 40 cows, and I kept one bull.
Okay.
So I would generally end up like 50/50. I'd keep a Simmental bull for a while.
Okay.
And I kept all my heifers for breeding, so they were 50/50, and so they would go.
Okay, you lean a little bit towards Simmental for 7 or 8 years, and then back and forth.
Right, and I always had really nice big calves. Calves were.
Yeah. I mean, the Simmental frame size is so much larger than the Angus.
I had
pretty good size.
Those people who know something about cows would recognize the fact I weaned one calf at 820 pounds. So, you know, you could, and I didn't give them steroids, and I didn't give them any grain, no grain, just on pasture and mother's milk, and you know, so.
See, I showed at 1,100 pounds. There's not much growth between that 800 and 11.
No, there's not. No.
Oh man, that's close.
So, anyhow, so that was my, and actually, I guess, take it a little bit further, I had a Santa Gertrudis cross, and I had a Beefmaster cross cow, and they turned out to be the absolute best gems in my whole herd, because the both of them, I kept them till very ripe old age, and they delivered heifer calves every single year. And I kept the heifers every single year out of them because they were just the greatest milkers, and that was the best that I had, actually.
So the Santa Gertrudis and the Beefmaster crosses were...
Oh, stupendous, you know. So anyhow, that's the cattle business, you know.
You want to talk a little bit about the work you did for the Navy?
Yeah, it was an interesting case where the Navy had come to this company down in Boston in the early 50s, and the idea was, geez, I hope I don't get arrested, but the idea in the 50s, it was so classified that they couldn't tell anybody what was going on, and the idea was to put these sonobuoys off the coast to be able to pick up, because in the Second World War, German submarines came right in close. So they were putting sonobuoys in the bottom of the ocean and connecting it with underwater cable. And so this company in Boston was an underwater cable company. And so they got the job for the Navy to put up a special plant in New Hampshire on the water. And the deal was that Bell Labs at the time, which was a high-tech communications company, Bell Labs were responsible for the system, and the company that I worked for was responsible to put up the factory and to hire the people, and Bell Labs was responsible for all the technology and equipment, actually, and it was a very lucrative deal. It was the longest-running cost-plus contract ever given by the government, and it just went from 52 to I think it's probably in the late 70s, I think it was, when they finally gave up. They decided they weren't going to do that. But as it is now, there's sonobuoys all through the Caribbean, up around the Greenland, West Coast, every place in the country, so it's underwater cable, and then we started doing fiber optic cable in the 70s, and did the first transatlantic fiber optic cable, which is interesting. It's really interesting work. It's where you really learned how to make really specialized equipment. And so what you do is you take the fiber, and you could go 13 miles in one length before you needed an amplifier. So every 13 miles across the Atlantic Ocean, there's an amplifier that's powered by a DC current. And so you would take this fiber optic cable and you would bed it in some soft plastic, and then you would wrap steel wire around it and for protection.
I was going to say, otherwise the pressure will eventually compress that plastic enough to...
No, because the plastic is what's the term for it? The volume won't change.
Okay.
So you drop it in the bottom of the ocean, then you put polyethylene around that, and then you put copper around that, so you can run copper between. You have a copper jacket over the steel wire, and so you put a copper jacket over the polyethylene, and then you would run voltage between the two coppers, so you can power the repeater, the amplifiers. And then you get done doing that, and then you have multiple lengths of these with an amplifier in between them, and you put them in these huge tanks covered in seawater so that the seawater can completely diffuse into the polyethylene, and that you have electrical properties, and you have to check the cables.
You have to pre-soak the cable almost.
Have to pre-soak them, that's right. And then every now and again the ship would come from Bell Labs owned the ship, the cable layer, and we would load it up, and then they would take it off and they would lay the cable. And so it was pretty neat because the fiber optic was one thing. The analog cable was pretty neat too. Before that, you run a signal between the two coppers. It was the same kind of deal. But what you had to do was you extrude polyethylene over the steel wire, and then you would run through this tool that was spinning around while the cable's going through.
Making that jacket. And
well, no, you were spinning it around with a ultrasonic detector to find the distance to the steel, because the steel would be, when you're extruding it, it wouldn't be exactly centered. So you would be continuously shaving while the wire is running through. You're spinning around, and then you're shaving it while it's going through, so you have a constant thickness. And then you put the copper over it, bend it around, but you can't get copper. Now, those were 26-mile ones. You can't get copper sheet that's 26 miles long, so you had to weld it, and so you had to do that on the fly because you're doing it all in series while you're extruding. So I can tell you it's exciting when a thunderstorm comes by, because you extruded 13 of 26 miles and you can't have the thing shut off.
Right.
So
you're just hoping you get another 13 miles for something.
Yeah. So that was really interesting work, and it got me involved in lots of stuff for the Navy. They came to me one time. They came to the company one time, and they said, "Well, we've got to rapidly deploy Marines to a battlefield somewhere in the Mideast, and it's very shallow. The water is very shallow coming into the coast, and so you need to be able to lay 2 miles of pipe from the tanker to the shore. And so what we're going to do is we're going to have the Marines weld a section of pipe together, and we're going to use a little tugboat, and we're going to pull out one section at a time, and the Marines are going to weld it, and they're going to do that for 2 miles, and they're going to connect it in the bottom of the ocean, and they wanted us to make a flexible cable, but with a hole in the middle, which would be a flexible pipe that would connect from the ship to the thing. And so I looked at that, and of course the military procurement's a funny system. So I looked at that, and I said, well, that doesn't make any damn sense, because it's going to take them for how long? They're going to be under fire on the beach, they're going to be getting shot at, and they're doing all this welding. I said, we're going to make a 2-mile length of cable, of pipe, and put it on a big reel, big huge reel, and you just tow that out, one thing. It's like hooking up oil to your house, you know, and we were very successful doing that. We made a couple systems like that. I remember going out to California to review some World War II tankers that we retrofitted with these great big huge reels.
So you were actually able to go see the
Yeah,
reels.
We had to pick one out that was suitable. The deck had to have certain strength for it, you know, and so it was interesting. You get to do a lot of different things, and then of course, you know, also brought us into doing that offshore power cable. That was really interesting. What happens is that the temperature of the water at the bottom of the ocean is 4 degrees every place, if it's deep enough anyhow. And on the surface, you're at like in centigrade, you know, you're like 80 degrees, not 80 degrees, you're like 20, 28, 30 degrees. So you can run a thermal cycle between the 4 degrees on the bottom and the surface water temperature.
Surface temperature.
Yeah. And so that was actually developed and demonstrated in the 1800s, I think. It was a long time ago. But it wasn't really commercially viable. So, but what we did for the Department of Energy was we developed a cable that would go from, in a depth of, what was it, 2,000 feet, I think, down to the bottom, and where we would hook up to a stationary cable. But the problem is that the ship is going through a hurricane, the floating platform.
Your floating platform has quite a bit
It's moving up and down.
motion.
And so these were the days before the powerful computers. And so we had to do all those calculations by hand. Now, if you take a cable or take a pipe or something, a string, and you hold it here and you bring it down to earth, that is a parabola.
Right.
And the mathematics of a parabola are not all that difficult. But in the water, you have a buoyancy element. And so now what you have is a catenary, not a parabola. And the math is much more difficult. So we had to do a lot of really high-powered math, and we had to do it at the very beginnings of the computer era. And we had to go get timeshare computers and stuff. And the equations that we had to develop ran, 6, 7 pages. It all had to be done by hand, the equations.
So you're saying the beginning of the computing era. Are you talking ENIAC, beginning of the computer area? Or you're...
This is the 1970s, so whatever was existing in the 1970s. There weren't that many computers. I remember it was difficult finding someone that could run the equation. And it was, it was technical papers and stuff like that. And it was a really big deal. And there was a test lab up in Montreal, Canada, that we used to have to, we had to develop a, company had to develop a testing laboratory to do fatigue tests and water corrosion tests. We had to develop a special grade of stainless steel, Monel, special grades of Monel for deep seawater immersion and surface immersion. And we took them to the special lab up in Canada, which was interesting. They had a laboratory building, a high voltage laboratory building that was 200 feet by 200 feet by 200 feet. It was a room that was a 200-foot cube, and it was lined with steel, so it was a huge Faraday cage. And they would put an electrode in the middle of the Faraday cage, and they would run not static charge, they'd run AC voltage up to the point they could run an arc 100 feet to the walls.
So they'd short to the walls from that electrode? Yeah,
from the electrode. And that could get us, we get up to, these cables had to be 700 kV. And it was, very interesting work. It was, so it was fun work. So when you kind of get into the industry, working with the Navy, working with the government, it's a different business, but when you're experienced at working for the government, see, that company would have difficulty with commercial projects.
It's a very different timeline. It's a very different
timelines, different accounting. It's very difficult to do accounting. In those days, commodity prices like today were very volatile. And so what the company had to do is they had to go out and buy copper futures contracts in order to cover their expenses because the timeline was so long.
Right.
I mean, so it was, interesting. We did a lot of different things over the years in that period of time. And, I've always liked to do new things, right? I mean, that's, something that's innovative, something that's a challenge.
So I was getting ready to ask you, so you're doing all this work on specialty cabling and power cabling and signal cable. Why did you make the industry change from specialty cabling to pressure vessels?
Yeah, well, I did actually pressure vessels was before that. It was before that, yeah. Okay. And that was fun too, because we developed that first LNG. The theory at the time was that they get this natural gas out of Alaska, right? Because they had these gas wells. You get a lot of gas out of oil wells, and so they had all this gas, and you're already at 20, 30 degrees below zero.
Right.
And so you can liquefy it more effectively than you can liquefy it when you're getting gas out of Louisiana, for instance, right?
There's less energy.
Right.
Taken to.
So what you do is you'd fill up these railroad cars, and then you would bring them down to the lower 48. And what happens is that you have a natural boiling.
Right.
You have a heat loss because the tank is at minus 270, I think, was LNG. I'm trying to remember. And so the heat would be going in, and so you would be boiling, and you had to, and by specifications, the tank car was only, I think, 25 PSI internal. And so what would happen is you would start to evaporate, but you would take that all evaporation from all these tank cars, you run them up to the locomotive, and you run the locomotive on natural gas, and so you have this big train, which is just running off just losses.
It's running off its own
losses. And at the time, I was working up in New England, and the Boston area was a pioneer in the use of liquefied natural gas because their pipelines, the city had grown so, and it was so dense that they couldn't put new pipelines in, and the pipelines were small, and so they couldn't, people living in the periphery in the Boston area in cold weather couldn't get any gas pressure. So they'd put LNG satellite stations up, and they would be able to keep up. And so we also made highway trailers to fill those, and so we extend that to take the trailer, the rail car. And so we did a lot of work with the Department of Transportation for development of a new tank car specification, which was interesting. I learned how to write legalese, in that case. The railroad industry had an interesting theory at the time that that anything that happens on a railroad track, any derailments, is nobody's business because it's all private property. See,
they still try to take that approach.
yeah, they maybe still do, and the government would say, yeah, but the pieces come out of your property, you know. But so writing regulation, we spent a lot of time writing regulation and doing a lot of engineering on a tank car, because the stresses in a tank car are really high. It's a railroad car, you know. We used to say, if you want to break a bowling ball, ship it by rail, you know. And so it was an interesting thing, and what happened is that I was doing that for a number of years, and then I kind of got interested in wanting to get into the underwater business. It was more interesting, and I did that for about 5 years, and then I took an MBA and thought that I would want to do a little more management, you know, and then I got into the automotive, doing instrument panels, which is an enormous. That's a tremendous business. You know, you get to be involved with kind of a car nut, and you get to be involved in cars from the very, very beginning. The stylists come in with renditions of what the car is going to look like, and they're very good people. They're very, very talented, and we would have to digitize that stuff and come up with drawings at that time. And in those days, we didn't have CAD. It goes back a while.
Done by hand at that point.
And so when you ended up with the drawing, it was on 43-inch, I believe, was the number format. The paper was 43 inches high, and it would go like the Dead Sea Scrolls. They were 30, 40 feet long, and they'd be rolled up on each side. And you'd have all these sections, because there's nothing straight on an instrument panel. It's all very curved, styled, right? So you have all these sections that you have to check. And so technology was very interesting. So that's why I learned something about high volume manufacturing and, you know, great efficiency and quality. That was at the time of the quality revolution. And we were fortunate to have had a company called Gold GPC, which was, I don't know if they're still there, down in Massachusetts. Now, Massachusetts, because of MIT, was one of the early computer savvy areas. You know, you had Caltech, and you had people out in California, but you also had a huge area in the Boston area, and they supported a lot of quality research, a lot of statistical research, and so we did a lot of that stuff early on. And in the company I worked for, doing the instrument panels, we actually had our own in-house statistician, and we had our own in-house person for employee participation teams. I really learned the power of teams at that point, collaboration. You know, you would take a team that was working on one production line, and you would pull them off the line for 1 hour a week, and you would set them up, and you would train them on how to do team-oriented problem solving, and then you'd set them free, and you'd say, okay, first thing you got to do is find a 5% reduction in labor cost, you know, to make up for your 1 hour. And that'd take them no time, because for all the industrial engineers running around, the people actually doing the work can tell you a whole lot quicker.
They always know more.
They always know more what's going on.
But no, thank you. I appreciate your time.
Well, it's enjoyable, you know, after so many years of working in this stuff. It's enjoyable to think back about the things that we've done, and it's been a lot of fun. You know, I can tell you it's been a great trip, and it really is the journey, not the destination. Thank you.
All right, thank you.
Thanks you.
Hi, everybody. Thanks for visiting our MACS YouTube channel. If you like this video, please subscribe. We have many others that you might enjoy. You can also find great content on our website, www.maxmobilairclimate.org, where I invite you to join MACS as a member and help support the quality, professional, mobile AC, information and training that you've come to expect from MACS through programs like these. I'm Steve Schaeber, and we'll see you next time.